Greetings to all. In this video, we'll be discussing about ventricular enlargement. And in theoretical portion, we have already discussed that if you want to find any abnormalities due to ventricular enlargement, then the basic leads that you need to focus are that is lead B1 and lead B6. So these are the two basic leads that you need to focus on. So why do you need to focus on these two leads? Let me explain it quickly. Suppose this is your heart. Okay, this is the heart, and let me divide it, and let me level it up. So let me fill it up. So this is right ventricle here, and this is left ventricle here. So when you draw the resultant vector, so from lead 1 the resultant vector will be this way, isn't it? So it will be this direction. From and from left ventricle the resultant vector would be in this direction. So when you plot the chest lead, so the chest lead B1 will be somewhere here, so B1 will be somewhere here, and B6 will be somewhere here. So gradually 2, 3, 4 and 5 will be here. So you see that the major portion of, so you see here the major portion of right ventricular depolarization is picked up by lead B1, B2, B3. So these leads they pick up, and major portion of left ventricular depolarization will be picked up by 5, 6 and to some extent 4. So this idea, basic theoretical idea you need to have. So now in normal case, I will draw a quick diagram. In normal case, suppose this is B1 and this is the isoelectric line. In normal case, this is just theoretical representation only. In B1, so B1 you see, so you see here, these are the individual vector representation, isn't it? This is the right ventricular depolarization, and this is the left ventricular depolarization. However, the resultant ventricular depolarization will be represented by this R line. So this is the resultant ventricular depolarization, isn't it? So it is going in this direction. So this resultant direction, this resultant vector is opposite the direction of B1, isn't it? So the resultant QRS complex in B1 will be mostly negative. So it will be mostly negative. However, in case of B6, so in case of V6, when I draw the isoelectric line, since the resultant vector is facing towards the V6, so it will be positive. So the maximum QRS complex will be positive deflection, isn't it? So this is the basic funda. So normally in B1 you will have negative deflection. In V6 the QRS complex will have positive deflection. However, in case of right ventricular hypertrophy, okay, let's say that now this right ventricle has been hypertrophied. So let's say this has hypertrophied, so this right ventricle has hypertrophied. Now what happens is that now this resultant vector, suppose let's say draw from green line, now this new resultant vector will be shifting, towards this direction. So you see this green line, so this is the new resultant vector due to right ventricular hypertrophy. So what happens, because of right ventricular hypertrophy in B1, so it is going towards the direction of B1. So in case of right ventricular hypertrophy, so let me write it here, in case of right ventricular hypertrophy, of right ventricular hypertrophy in B1, so this is B1 and I draw a isoelectric line. So in you see here, this is the case of right ventricular hypertrophy, isn't it? So the maximum vector is going, the maximum resultant depolarization vector is coming in this direction, so it is most effectively picked up by this B1, so the deflection will be positive in B1. So the resultant QRS complex will be looking like this. So there will be positive deflection in B1. However, in V6, you see that the resultant vector is in this direction, which is opposite to V6. So V6 is here, it is opposite. So the resultant vector is going in opposite direction. So the deflection in V6 will be negative. Suppose I draw isoelectric line in V6 and the QRS complex will be negatively deflected. So this is the fonda in right ventricular hypertrophy. Okay, now let's say suppose there is left ventricular hypertrophy. Okay, let me write it down here. Suppose there is left ventricular hypertrophy, then what happens in left ventricular hypertrophy then? Now let's take another example. Suppose this is your left ventricle and this left ventricle, now it is being hypertrophied. So left ventricle is being hypertrophied. So what will happen? The resultant vector will be shifting to this direction, isn't it? Because it is hypertrophied. So the resultant vector will be shifting to this direction. So this resultant vector which is being shifted to this left side will be picked up easily by V6 because V6 is here. So when I say here V6, so when I say V6 here and I draw isoelectric line, then because of left ventricular hypertrophy which is going towards V6, the deflection of QRS complex will be positive. However, if we talk about B1, since the resultant vector is going towards left direction which is against B1, so B1 is here, so it will have negative deflection. So B1 will pick up negative deflection. So if we draw isoelectric line in B1, then because of left ventricular hypertrophy there will be negative deflection. Now let us jump into this ECG. So we are jumping into this ECG. So now let us first of all look at B1. So this is our B1, you see here. So in B1 what you can see is here the R wave is very much high. You see the R and S ratio is greater than 1 and the magnitude of R wave is greater when you look at the guideline, and you see similarly the V2 magnitude is also greater, V3 magnitude is also greater. So you see here the V1 is what? The V1R magnitude is greater, and again now you compare with V6, you see here V6, in case of V6 here the negative deflection is slightly greater than the positive deflection. So you can say that this is the case of right ventricular hypertrophy. So you have different criteria. So you see here to tell right ventricular hypertrophy you need to have right axis deviation, which we will be finding out, and dominant R wave in B1. So you see greater than 7 mm tall or R by S ratio is greater than 1. So this you can find here. So you see here the dominant R wave, and other supporting finding there can be like right atrial enlargement and different things you can read. Again going back to that figure, when we look at, so you see here right atrial enlargement, it's not quite clear, but when you zoom it out it could be visible, I hope so. So you see here the P wave, it is like tall P wave, but it's not clear. But what we can do is that we can find the axis here. So to find the axis, what I would like to do is that I will draw lead 1. So I will draw lead 1 here. So this will be our lead 1 here. So let me label it here. So this is lead 1, isn't it? This is lead 1, and another I will draw AVF, and I will draw AVF here, and I will label it as AVF. So this is A, V and F, and now I will draw the vector. So when you see here the lead 1, you see here the QRS complex, the resultant deflection will be negative. So when you draw the vectorial representation of it, then the vector will be going in this direction, that is negative to lead 1. So from here to here it is going in negative direction. Whereas in case of AVF, so you see here, this is the AVF here, right here. So this is the AVF, you see there is the positive deflection. So in case of AVF, the vector is going in positive direction. So in AVF it is going like this. So green line it is representing, and you see, so it is going like this. So you compare the magnitude, and then later on you draw imaginary line, perpendicular line. So I draw a perpendicular line from here. So this is the perpendicular line, okay, and from here I draw another perpendicular line, and you see these two perpendicular line meet at certain point. So this is the point where they meet, and when we draw the resultant vector from here to here, so it comes like this. So you see the resultant vector. So now you draw the angle. So this angle is of course greater than 110 degree. So it is the example denoting that it is right axis deviation. So from here, one additional feature, what information you got is that this is the example of right axis deviation. In B1, the R is to S ratio is greater than 1, and the magnitude of R wave is greater than 7 mm. You see how tall is the R wave in comparison to the S wave. So you see the very high peaked, you see, greater than 7 mm. So you read the guideline, and yes, the P wave, it's not like quite clear, we need to zoom it up. So you see here in lead 2, let me zoom it up for you. So it's not greater than 2.5, so it's like 50-50, a bit confusion, but yes, it is not like a tall P wave, it is not clear. So right atrial enlargement it is not seen. However, this is the case of right ventricular enlargement, and right axis deviation is seen. So this video shows which lead to look at. So always look at B1 and V6, and other neighboring electrode also you can look B1, B2 and B5, V6. And if there is right ventricular hypertrophy, then B1 will have positive deflection. You see here it will have positive deflection, whereas V6 will have negative deflection. In case of left ventricular hypertrophy, B1 will have negative deflection, whereas B6 will have positive deflection. So I would like to conclude this case here. Thank you.